So we're gonna do this one long division, just like we did last Thursday. Talk about long division. Before you deploy the division algorithm, you have to follow these steps. You must prepare it. You have to write the dividend and the divisor in descending powers of the variable. So the variable has to go from the biggest power down to the smallest power. If you arrange them in the correct order. Okay. And you also have to have placeholders with a zero coefficient if you have any missing powers. So if the biggest power is x squared, you have to have an x squared, an x to the first, and a constant. If you're missing x to the first, you put 0x to the first in the middle, have a placeholder. If you have an x to the fifth, you have to have an x to the fifth, an x to the fourth, an x to the third, an x to the second, an x to the first, and then a constant. All the place values have to be there. So things line up and you subtract correctly. Yeah.
So on number 17 in the homework, they were completely mixed up and I was like brainstorming. Are you allowed to?
No, that's absolutely right. Yeah.
Okay.
You just gotta make sure the sign goes with it. So that's why I mixed this one up. Okay. I mixed this one up. Now I'm going to show you this one. And then we're going to do it again using the new technique that we're going to talk about, synthetic division. And when we do synthetic division, it's going to go so much quicker. But synthetic division only works under certain circumstances. It has to have something that has to be true in order to apply synthetic division. If it's not that kind of a problem, you can't do it. You got to go long. Okay. Before I even write this into the division, so before you can do this, I'm going to make sure everything's arranged and everybody's there. The biggest power is x to the fourth. So x to the fourth, you're going to stay put. Then I'm looking for an x to the third. I don't have an x to the third. So we need an x to the third. First two rows, find one. There you go. Don't worry. So since we don't have an x to the third, you have to put that placeholder in there. We need a 0 x to the third. Okay, 0 x to the third, just it's 0, but it's going to be a placeholder. And then we look for our x squared. We have a negative 10 x squared. So that one. Now I look for my x to the first. So here's the deal. That's not an x. That's the constant. This will be the last term. There's the x to the first. So keep the sign. It's a negative 2x. And then that's my x to the first. This is x to the 0. This is 4 times x to the 0 power. All right. Golden oldie, back to the very first week of classes. Rules of exponents. You see that over there? Number 7, 4 times f of 0. Over here, f of x equals 2 to the x. So f of 0 is going to be 2 to the 0. Anything, everything to the 0 power except 0. Can't put, 0 to the 0 doesn't work. That's indeterminate. But everything to the 0 power is equal to
1.
Yes. Everything to the 0 power is 1. It is a given. It is one of those rules of exponents. That if you're going to survive chapter 4, you have to know your exponent. Negative exponents, power of 0, fractions, 5 to the 1/2, what that means. So this is 4 times x to the 0. Well, let's put it this way. You said 0. So if it was x to the 0 was a 0, that would be 4 times 0. Then you know what? That could never be a 4. Because if x to the 0 was 0, 4 times, that would be a 0. So that ain't it. This is, if it's a 4, it would be 4 times a 1. So x to the 0 is 1. That's how we get the 4. It's the x to the 0 power. Everybody has an x there. See, the powers go like this. 4, 3, 2, 1, and then you have your x to the 0. You don't put it, you just put the 4. But then it would go x to the negative 1, x to the negative 2, x to the negative 3. What do the negative powers do? X to the negative 1, 1 over x. X to the negative 2, 1 over x squared. And negative rules for exponents. Okay? If that's happening, it's no longer a polynomial. So it would no longer be one of these questions. All right? Because this is a rational expression, not a polynomial. But that's how the powers go from biggest to smallest. You keep going this way until we get to the constant. And then we're still divided by an x plus 3. So the divisor, x plus 3, goes here on the outside. And the dividend goes right here underneath. X to the 4th plus 0x to the 3rd. And then minus 10x squared minus 2x plus 4. Long division. Only thing you care about, the only thing you look at, the only thing that matters is this first term x and that first term x to the 4th. We want to multiply this x times something that will make x to the 4th. So if you have to, and maybe you just do it a couple of times and then you start to get the hang of it, you're going to focus on this x times what to make 1 times x to the 4th. Look at the coefficient. This is a 1. So I don't want to multiply by any number out here because I still just want 1. But what times x to the 1st would give me a 4? Well, let's not guess. Let's look at it from this perspective. Here's your choices. It's going to have to be under or over one of these columns. If you choose x to the 4th, if I decide to start with x to the 4th, x to the 4th times x to the 1st, that's an x to the 5th. Because you add the powers. I don't even have an x to the 5th. So I wouldn't start right above the x to the 4th. So slide over 1 place value, which is why we need that placeholder, the 0. If I start with x to the 3rd, x to the 3rd times x to the 1st, that's x to the 4th. So the very first term I'm going to start with, what times x makes an x to the 4th? It's going to be an x to the 3rd. And it's going to be put right here in the x to the 3rd place value. That's my choice. What times x is x to the fourth? X to the third times x is equal to x to the fourth. But now you actually do the multiplication. When you do long division, you figure out what am I going to multiply by, and then you actually multiply. So now there's my choice. I'm now going to pick that x to the third times the whole divisor, the x plus 3, because I need to know what I'm going to put down there and subtract. Long division, algorithm. Algorithm is that, what do I do? What's the recipe? What's the churning going to happen? I pick x to the third. Now, what do I do? I turn the crank, and what happens? We distribute x to the third times x to the fourth, x to the third times 3, 3x to the third. So I'm going to get x to the fourth, and it needs to go right here. And then I get 3x to the third. And then you're going to subtract. Don't be lazy. Put that, when you subtract, you put a little line there. And what I told you last week is when we subtract, you're going to subtract each one. So you would put minus the whole thing, so that would be minus the parentheses. You would distribute the negative, so let's just distribute the negative, subtract each one. This better cancel first two rows. X to the fourth minus x to the fourth, better cancel out. It better be 0. That's why we chose x to the third. It does. Then over here, 0 x to the third minus 3 x to the third. 0 minus 3 is negative 3 x to the third. 0 minus 3, negative 3. And I have x to the thirds. And it's right in that column. Place that. So the messy people have to really be careful. The right big people might want to clean it up right a little tinier. Not tiny, but just organized. Then you bring everything else right along with it. Minus 10x to the second minus 2x plus 4. And then you do it again. And now the focus is just on the first two terms. And you're, again, still looking at just this x and just this first term. So this x times what is going to give me that negative 3 x to the third. First thing I'm going to look at is I need a negative 3 times it. I need the coefficient to be a negative 3. So I'm going to have to multiply with a negative 3. There has to be a negative 3 to give a negative 3 over there. It needs a negative 3, so I have to have a negative 3. Well done. Then, what times x to the first will give you x to the third? What column am I going to be in? Yeah, there's a big clue. There's a huge clue. I'm not going to go to the left. I'm going to go to the right. So the next column over would be an x to the second. And x to the second times x to the first would be x to the third. So negative 3x to the second times x is negative 3x to the third. That's going to be my next term. Negative 3x to the second times this x would give me this. So now we actually have to do the multiplication. We take that negative 3 x to the second times the whole divisor, the x plus 3. You got to remember to multiply times the whole divisor. We distribute negative 3x squared times x is negative 3x to the third. And negative 3 times 3 is negative 9x to the second. Let's see what the camera's going to pick up better. I know it's dark up there. Can you still see? Okay. All right. So here's got negatives. When you subtract, this is why it's important that you show this part. Subtract each one. So minus and a minus. Don't just automatically just change them. Minus and a minus. Negative 3x cubed minus a negative 3x cubed. Those two become a positive, and you're going to subtract a negative. Two consecutive negatives make a positive. This better make 0. Negative 3x cubed plus 3x cubed make a 0. Cancel out. And that's what's supposed to happen. And then here, negative 10x to the second minus a negative 9. So that becomes a positive. So it's actually negative 10x squared plus 9x squared. So it's negative 10 of these x squared plus 9 of those x squared.
It's negative x squared.
Exactly, negative x squared. Negative 10 of them plus 9 of them is technically negative 1 of them. But we wouldn't write the 1, we would just go it's negative x squared. The 1 is implied there. Now, again, think about where we're at. We're in the x squared column. We only have 2 place values left that we have to go at the most. And then possible remainder. So the focus is this x and a negative x squared. So what times x is going to give me a negative x squared? First of all, the coefficient's a negative 1, so I'm going to have to multiply by something that's negative. A negative times a positive would give me the negative that I need. And then what times x would make x squared? There's another x. A negative x times an x is a negative x squared. X times x, x squared, and I need it to be negative, so I have a negative times a positive. So my next term in the quotient is negative x. Right above the x column. Or it should be. Now, here's where I hope you get to. You don't have to. But here's where I hope you get to. You know, once you make the choice, you have to multiply it times the entire divisor. And what we've been doing is we've been doing the distribution over here on the side, which is perfectly fine. You just got to manage your space in the test problem little box. But I'm perfectly fine if you do it here. Negative x times positive x would be a negative x to the second. Negative x times positive 3 is negative 3x. This negative x times the first one, distribution, and then negative x times the second term, distribution. Now, you don't know if that's freaking you out, then write it over here. Negative x times the whole divisor. Negative times a positive is a negative. X times x is x squared. A negative times a positive is a negative. X times 3 is 3m. Subtract again. Minus and a minus, that becomes plus, that better make zero, it does. Minus negative 3x, so we're subtracting a negative, becomes a positive. What's negative 2x plus 3x? Positive x, it's x. I got negative 2 and a positive 3, so basically 3 minus 2 is 1. So 3x minus 2x is 1, and then plus 1. And we're in the last column, x to the third, x squared, x to the first. The last column should be the constant. And we're looking at x, and we want x. What times x is just an x?
One.
1 times x is just x. So the last term over here has to be a plus 1. You have to have something there to actually make it happen. You still have another something we have to subtract from. So it's going to be 1 times the x and 1 times the 3. 1 times x plus 3 is just x plus 3. Because who knows, maybe there's a remainder. We subtract.
We're always getting nothing.
For the long division, yes, because that's how we did long division with just numbers. Multiply, subtract, do it again. Long division. Cancels, we get 0. 4 minus 3, 1. X does not go into 1. So that's the remainder. And then you go plus, always plus, and you put the remainder over the divisor x plus 3. I'm putting this up here for later. Now remember, division questions can also be written as a fraction. I wouldn't need a parentheses if it was written like this. And the answer is that's a little bit of review from last Thursday. So we'll come back to that in a bit. Here's our preview for 4.1 and 4.2. Exponents. Exponential function. This semester so far, we've been living in polynomial land, linear land, polynomial land. Is that? Okay. Been living in the land of this. Linear, y equals 3x to the first plus 2. We've been living in x squared plus 4x minus 7. Okay. 3x to the third plus 5x squared minus 2x plus 8. Polynomial. We've even done some square roots. Square root 5x squared plus, not plus, we'll just go 5x squared. So we've done some radicals. We've done some rational x plus 3 over x minus 4. We've done some imaginary, we've done a few things. And you can send them back your butt, because you're not in this class. The difference between where we've been and where we're going. This polynomial, the base is the x. We're raising it to the second. So whatever has happened, the base is changing. We're plugging in different numbers for the base. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. Here, we're changing the exponent. Take a look. Which one do you think is going to go bigger faster? So I'm just going to start plugging in some numbers. 1 squared, 2 to the first, 2 squared, 2 to the second, 3 squared, 2 to the third, 4 squared, 2 to the fourth. So 1 squared is 1, 2 squared 4, 3 squared is 9, 4 squared is 16. 2 to the first is 2. So this one's winning. Oh, I forgot. 0 squared, 0. 2 to the 0 is 1. So at 0, this one's winning. But then at 1, this one's still winning. At 2, when you plug in 2 for x, they're tied. When you plug in 3 for x, this one's losing. When you plug in 4 for x, they're tied again. Then we plug in 5. 5 squared is 25. 2 to the fifth is 32. 2 to the x is winning again. 6 squared is 36. Plugging in 6 for the x. 2 to the sixth is 64. 7 to the second is 49. 2 to the seventh is 128. Plug in 8. 8 to the second is 64. That's not getting a lot bigger. So 2 to the 8th is 256. Let's just go to 10. 10 squared is 100. 2 to the 10th is 1,024. 2 to the x is ever going to lose? No. Exponential functions are a lot. They increase much more quickly than most every other function. One that will outpace an exponential function is a factorial. Factorials grow faster than exponential function. That's a different story for another time. But exponential function, we hear about growing exponentially. The base is a given number, we change the powers. Okay. This time, it's just every time it's just double. Double it 2, double it 4, double it 8, double it 16, just double it. If you start with a base of 3, it's going to triple every time. Start with a base of 4, it's going to multiply by 4 every time. Okay, that's how you do exponential values. So these questions right here are going to rely on a couple of things. On G of 3. From chapter 3, do you remember what that means? Do you remember? I'm sorry, from chapter 1. Do you remember about just substituting the number into the function and evaluating? Number 2, for some of these down here, do you remember the rules of exponents? The G of 3, we're going to plug 3 into the G, so we're going to get 9 to the third. So G of 3 is equal to 729. Two things are really important. Number 1, it is not 9 times 3. It's 9 to the third, which means 9 times 9 times 9. Second, if you write 9 to the third, well, that doesn't even look like 9 times 3. That looks like 9 to 3. So what you write is going to be exactly what you think it's going to be. If you don't write it as an exponent, you won't see it as an exponent, so you will not do the exponent. Another thing. What I've noticed, I only have corrected individuals when I hear them say it. I haven't actually addressed it as a class, and I'm thinking I might need to address it as a class. That's 3 squared, or 3 to the second power. It's not 3/2. But when we have x squared, it's not x2. And I hear a lot of people every semester saying x2. And I'm going, I never say that. Where is that coming from? Because it's not isolated. And I think that's what, a lot of times when you're doing some of these questions, it's like you're hearing your inner voice say x2, so I see people doubling it, not raising it to the second power. And they're getting it wrong. So if you have that language, and if you don't translate it correctly, you do the wrong thing. Why is it a square? Why do we say x to the second power? Why is a power of 2 a square? And why isn't x to the third called a cube? Anybody know? Well, you're about to. Okay? Area. When we calculate the area, let's just say of a rectangle. This rectangle is 3. Now I should have made it 4. It's 3 and 3 by 4. So it's 3 this way. Let's just say 3 inches this way. And it's 4 inches this way. So there would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 inches squared, or 12 little square inches. Those squares in there. But why squared? Each one of these little squares, 1 by 1, they're all 1 inch wide, and they're 1 inch tall. So each of these little squares, when you break it down, is a 1 by 1. It's 1 inch by 1 inch. And so when you multiply 1 inch times 1 inch, you get 1 times 1, and then you get inch times inch. So you get inch to the second power, and you have a 1. When you want to not count them all, you just go 3 times 3 inches times 4 inches, and you get 12 inch times inch, inches to the second. That's going to be a pain in the neck when you say area is 12 inches to the second. We break down area into these little squares because the squares are 1 by 1. They're always 1 by 1. 12 little squares, 12 square inches. Area is flat. Area is always flat. Flat means 2-dimensional. Power of 2. That's why it's a square, because it's got 2 dimensions, and the area that we calculate is always power of 2, and the simplest area shape you're going to get is a square. The simplest area that we would get is that we always slice it up into squares. We always slice them up into little squares. Or x to the third. That's cube. Or let's just say it's a big box. Maybe this is 3 and this is 4 and it's 5. 3 by 4 by 5. And we want to know what the volume is. Well, when you have something like this, you just multiply 3 times 4 times 5. The area of the bottom would be an area down here, 3 times 4. It's 12 square inches down here at the bottom. And then you multiply how tall it is. 12 times 5, the volume is 60 somethings. Well, at the bottom, the area is in squares. You got little squares down here at the bottom. 1 inch by 1 inch. And then you have tiny little cubes that are 1 inch by 1 inch by 1 inch. 1 inch, 1 inch, 1 inch. So that would be inch times inch times inch, inch to the third. One tiny little cube is what we slice volume into. A square is the simplest area shape. A cube is the simplest volume shape. A cube is 3-dimensional. We have 3 dimensions: length, width, and height. So a power of 3 is just, we call it a cube. Power of 3 is a cube that represents 3-dimensional shapes. Okay. Square, 2-dimensional shapes. Power 2. But we don't say x3. We don't say x2. x2 is equal to the X-Men movie, and x3 was the crappy sequel to the first 2. Okay. Directed by Brett Ratner. I saw Brett Ratner at Comic-Con. I said, thanks for ruining the X-Men universe. Seriously, I did. I don't know if they heard me, but I was walking right past one. Idiot. But you, yeah.
Simplistic question here. So the reason that it is a cube, or the reason it's cubed with the 3 is because you have the 3 separate numbers that are going into it.
Right, because also it's 3-dimensional.
Okay.
So to get the volume, I have to multiply length, width, and height.
Okay.
And how do you find volume no matter what? It's the area of the base times how tall it goes.
Okay.
So that's going to be 3 dimensions. The area of the base is 2 dimensions, and then there's 1 more dimension. So you're going to have 2 dimensions on the bottom. So that's going to be a square.
Okay.
Times another dimension going how high. So that would be feet times feet times feet, feet to the third. Mile times mile times mile, mile to the third. So cubic centimeters.
Okay.
Because it's going to be centimeters times centimeters times centimeters. Cubic centimeters, we measure water, or if you're going into nursing, sometimes they do medications or IVs in cubic centimeters. Sometimes they do it into liters, whatever. I know my son is a vet tech over at Abbey Pet Hospital. And right before, I don't know what holiday it was, but they had, I think it was Vet Tech Appreciation Week or something like that. They gave all the vet techs a quiz. It was like, fastest quiz and do all these math things. And you could do the easy quiz or you do the hard quiz. I think he was the only one who chose the hard quiz. But it was convert all of these things, cubic centimeters into the metric system, or the volume measurement, the liters or milliliters or whatever. And it's like, Dad, I don't know why nobody else wants to do the hard ones. And I said, that's because you're a nerd. They don't want to challenge themselves. So you also dropped out of aerospace engineering. I don't think they did. I don't know. You had a different set of your mindset. You were a lazy college student, so you didn't anyway. But you're also happy now. You need to play with dogs all the time. Anyway, so how you write it, how you say it does matter. You got to speak that language. When you write it, it's an exponent, superscript, f of 5. So that becomes 2 to the 5th power. F of 5 is 2 to the x, so it's 2 to the fifth. 2 to the fifth, 32, because I know I gave you that chart, and I know you filled it in, so you know that by heart. Or you punch it up, or you write 2 times 2 times 2 times 2 times 2, and then 2 times 2, 4, 2 times 2, 4, times the 2. 4 times 2, 4 times 4, 16, and then times the 2. 16 times 2, 32. Or 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Or you punch it up. Or you just know by heart that 2 to the fifth is 32. Okay? All of the charts that I've given you, all those little tables, they're still there in the announcements. That would be the easiest place to find them. Rules of exponents. Okay. The powers chart, the table of exponents. Then, speaking of rules of exponents, number 3 and number 4. So first thing, write this out. G of -2. Write exactly, show the substitution. That's 9 to the -2 power. Now I understand 9 to the second, 9 to the positive, 9 times 9. But how do we multiply 9 times itself -2 times? The answer is you don't. No. Okay. Number 1, a to the m times a to the n is a to the m plus n. Number 2, a to the m to the n power is a to the m times n. Number 3, ab to the m is equal to a to the mb to the m. Number 4, a over b to the m is equal to a to the m over b to the m. Number 5, a to the m over a to the n is a to the m minus n. Number 6, a to the first is just a. Number 7, a to the 0 is a 1. Oh, here it is, number 8. A to the -m is a reciprocal. A to the positive m. You flip it. Then you do the problem. I knew it was there somewhere. Okay. Or if it's 1 over a to a negative exponent, then you flip it up. And then you'll a to the positive m, and then you can do the power. But you don't do a negative exponent, try to figure it out. You rewrite it. You rewrite it. This is 1 over 9 to the second. So it's 1 over 81.
So you get to put 81 in wrong?
If I said, you can have one, you can have this cake, but you only get 181, you get like one little tiny slice that's 181, or you can have 81 cakes. Are they the same thing? No. You get a little tiny little sliver of a cake, or you get 81 whole cakes. So they're not the same number. Okay. So yes, 81 is not right. Because 9 to the second, 9 to a positive, that's 81. So 9 to a -2 can't be 81 as well. That would be crazy. Can't have like two answers for the different questions. Not math. So f of -3 would be right 2 to the -3, and we don't do that. it's 1/2 to the positive root. That one we did quite a bit of because we did it with our square root. And whenever we did square root of 8, I kept saying, all right, from now on, we're going to always say 8 is 2 times 2 times 2, 2 to the third. Okay, save a little time instead of going 2 times 4, and then 4 is 2 times 2. 2 to the third is 8. 8 is 2 to the third. This is 1/8.
So when it's a negative, always be sure to put that one with the.
Yeah, because it has to be under something. And here's what is actually going on.
Like you said, two answers.
Right, and okay, and first of all, here's the rule. This is the rule, but here's why. There's always a why in that. We don't just make this. So that f or g of -2 is this. So we get 9 to the -2. Well, that is exactly the same as 9 to a 0 minus 2. 0 minus 2 is negative. Okay. Now it's this rule right here. I have 0 minus 2, subtraction. When I have subtraction, I can write it as a fraction. I can go this way because it's equal. So the first one is the numerator. The subtraction is in the denominator. So this would be 9 to the 0 over 9 to the second. And 9 to the 0 is 1. So 1/81. Okay.
So you're just simplifying. Right?
Yeah, so we can just do this now. We just do that. Yeah. Here they come, the fractions. Here comes your 1930s breakdown. First thing, just substitute. So g of 1/2 is 9 to the, again, 1/2 subscript, superscript. Now, 9 times itself 1/2 a time, that's not, we don't understand. There are 10 rules of exponents. The 9th rule of exponents. A to the 1 over n, and we talked about this in the last chapter. When you have a fraction as an exponent, the denominator, the n, the index, it tells us what root we're taking. The base is the radicand. It's the nth root of the a. That's how you convert a rational exponent. So 9 to the 1/2 is the second root, which is square root of 9. So this is just the square root of 9. You don't put a 2 on a square root. So square root of 9 is what? Just 3. Now we're simplifying, we're not solving an equation. So it's not plus or minus, it's just 3. So g of 1/2 equals 3. It's not 9 times 1/2, it's 9 to the 1/2, which means square root of 9, which is 3. Half of 3/2 would be 2 to the 3/2. So that's rule number 10. And rule number 10 is if you have A, not just to 1 over n, but to an m over n. I can rewrite this two different ways. I can rewrite it as the denominator is always going to be the root, is always going to be the index. So it's going to be the nth root. A goes here as the index, sorry, the radicand. The numerator is always going to be a power. So we do that. Here, let me do this differently. M is always going to be the power. So I can raise A to the M and then take the nth root of it. Or, there's an or. It's the nth root of A. I can do the nth root first and then take that answer to the M power. It just depends upon what you're working with. So I can either raise it to the power and then do the root, or take the root and then raise it to the power. It just depends upon what you're doing. How will you know? Practice. I know you might want to say that. So this would be the denominator's a 2, so it's a square root. The base is a 2, so that goes in here. And I can either do this problem by raising it to the third first, or raising it to the third afterwards. Okay. Now, over here, what is 2 to the third?
8.
8. But then I would have to see who breaks out of jail, right? So wouldn't that square root of 8 just go 2 times 2 times 2? And over here, don't I already have this 2 times 2 times 2? Either way. So how many 2s are going to break out?
2. 1.
Just 1 2 will break out alone. And then who's going back in jail?
A 2.
So 2 square root 2. Okay. This right here is square root 2 times square root 2, square root 2. Square root 2 times square root 2, since it's a perfect square, is just 2 times that square root 2. That's not as good. I think I like the other one better. But I want to show you one last little thing. It's kind of nice. 2 to the 3 over 2. How many times does 2 go into 3 even?
1.
What's the remainder?
1.
So 1 and 1/2, right? So that means 1 2 will escape, and there's a remainder of 1 2 back in the square root jail. If I had 2 to the 5 over 2, 5 over 2. How many times does 2 go into 5?
2.
What's the remainder?
1.
1. So 2 2s will escape, and there will be a remainder of 1 2 back in jail. So this would be 4 square root 2. So we'll go a little deeper into that. Let's do that last one. We'll be quick. G of 1 plus 4 times f of 0. G of 1, so that's 9 to the first, plus 4 times 2 to the 0. What's 9 to the first?
9.
9, good. That was a trick question. What's 2 to the 0?
1.
What's 4 times 1? What's 9 plus 4? It looks ugly, but we just substitute and simplify. All right, we're back at 10. I think I got, let me see if I don't think I have everybody, but I'm pretty sure close.